over to Todd. All right, Todd, would you introduce yourself and go forth with your presentation?
Sure. So my name is Todd Fine. I'm a PhD student in history, actually, but I've always been involved with hackerspaces for about 5 to 10 years now, and I think, like one of the other people who spoke, I'm always interested in what tools are out there, what is new, and VR seems like it's at a time where the hacker community and people who are creatively minded need to figure out what this technology entails. We're at a moment where there's this boom in VR, but a lot of people still haven't figured out all the business purposes and how it can be used. So I think it's a good time for creative minded people, hackerspace type, makerspace people to investigate it. I have some specific interests and I've done a little bit of programming in it, but I'm not speaking as a super expert. I'm just speaking as somebody who's been using the Oculus Rift that we have at MakeHaven, and we'll talk a little bit about what is happening in VR, what tools are available, and help people at least understand their options if they want to get started in programming in VR. So some people would say there's a new boom in VR. I mean, I'm sure everybody, when you read the tech press, people are talking about lots of investment in VR. You see these VR headsets, but it's not quite at a point where everybody considers it necessary. And a lot of the technology that's in these VR headsets in of itself is not new. The people have been making these, VR virtual reality headsets since the 60s and 70s, but it's never been an affordable consumer product like it is now. And I guess this current boom in VR can be dated to about 2012. There was a Kickstarter for the Oculus Rift, which is kind of, some people may know, is the I don't know, one of the dominant players in this space, an American company. And it was just a hobbyist named Palmer Luckey, who's a young guy. I think he was in his 20s, early 30s. And he had been buying up these much more expensive headsets and trying to replace parts and figure out, what made them work. And you could buy, 10 years ago, you could buy VR headsets for, $5,000, $10,000 that could do a lot of the things that the headsets today can do. He posted a Kickstarter to actually create a new headset and started to be endorsed by some tech giants, like people may know ID programmer John Carmack, the maker of Doom, and Gabe Newell from Valve. And in just 3 days, his Kickstarter got $1 million, and it ended up getting multiple millions of dollars. And then people were able to eventually, within a year, buy a developer kit for this Oculus and start making programming. And then in 2014, Facebook actually acquired it. So the question is, well, what was the key innovation in this new boom in VR? And it wasn't necessarily any change in optics. It was actually just using the software to create the stereoscopic images for lenses on the device, rather than in the past where they had these complex, heavy optics that would operate on a magnified image within the headset. Now, a lot of that work is done through software beforehand, so the lenses can be much simpler. You also have cheap mobile phone screens that allow very good effective resolution and frame rates. And then, since these devices have been made commercial, you have a lot of different experimentation and fine-tuning consumer grade motion sensors and different motion tracking ideas, sometimes with stations or without stations, sometimes with lasers. You have non-optical sensors that operate on the movement within the space, or just the gyroscopes. So if you've been following the devices, each device has a different motion sensing device. Increasingly, we're getting cameras on the device with the processing power to actually navigate the space that you're in which is greatly increasing the accessibility of these things, because you don't have to have hardware components. You don't have to have stations with cameras around your room. You don't have to have a clear space necessarily. So the consumer products are innovated rapidly, and there's a lot of new things coming on board. Facebook acquired Oculus in March 2014, and there's now a fairly good competition in the market with Valve, HTC, and Magic Leap, all having their own consumer headsets. So what are the different VR devices? So you have, so somebody mentioned that the cell phones these days have screens that are good enough quality to just put in those headsets that you have. And there are SDKs that are built just for that type of programming. Google has an SDK for that. Oculus also has a mobile, and an SDK, for people who aren't familiar, is kind of a library that can be used to access the hardware features on these devices. Typically, they create hooks into those libraries for all the different standard programming languages that people would use, like Java or C++ or whatever. Now, the key difference between your phone and these headsets is the degrees of freedom. Usually, the cell phone VR can only operate around a stationary point where the phone is operating. It can't move in 6 degrees of freedom, where you're actually able to move forward or backwards or strafe or go up and down. It just can operate around a single point. So it's almost like the phones are kind of like you're operating on a roller coaster. You're in place, you're seeing things around you, but you don't have the full ability to move around. The tethered devices, though, which tethered connected into the computer, give you this additional degree of freedom where you can move around, you can crouch, you can move from side to side, you can move forward and backwards. And the major ones are HTC Vive, Oculus Rift, PlayStation has one, and then actually Valve, the large gaming company, just developed one called the Index, which just launched a few months ago, and it's now considered one of the leaders. So all these different companies are trying to leapfrog over each other to get to innovate in this space. So what are the differences between these different devices? Each one has slightly different field of view, which is the amount, the angle from your eye that you can see within the space. They have different devices, use different types of display. Interestingly, the Valve Index chose to do an LCD display versus some of their competitors, which use OLED displays. The LCD display allows for greater frameworks, but doesn't have all the contrast and the colors of the OLED displays. You have differences in whether there's onboard audio and the quality of the positional audio, the ability to have audio in 3D. Differences in the controllers. This is, for example, this is a controller for the Oculus Rift that the space has, and they just have different ways to use the controller. Some of them allow you to grab things, to put out your index figures. They have actually some sensors on the controllers now that can detect how your fingers are moving, and different ways that they do positional tracking, whether it's with the camera looking at the controller or whether it's connected to some other element in the space with a laser or infrared light or other things. Now, the one huge innovation, which some people think may change the market, is the beginning of untethered devices. The tethered devices require you to be connected to your computer. The untethered devices have actually a processor on board, like the cell phones do. But this is one is very fine-tuned to manipulate such types of images. So Oculus has the Oculus Quest, which has basically been sold out for the past 5 or 6 months, and you have to get on waiting lists to get it. It's battery powered as well, and so you can take it out to a park or wherever you want to go with it. But now, just a few months ago, they also launched a fiber optic link cable so that it can be tethered as well. So you can use your GPU and have this device, so you get the best of both worlds. So what can you do with VR? As I mentioned, there are lots of startups. There's a link from TechCrunch that said that the startups in the VR AR space are valued at $50 to $60 billion. But if you follow it, there's been a lot of talk, just like with the gaming boom in the 1980s, where you had Atari and everybody thought the gaming was the future, but then there was a crash in the mid 80s until Nintendo came back. There's been some suspicion that's happening with VR, because 3 or 4 years ago you were probably hearing a lot about this, but there isn't a game. I mean, nobody's saying, oh, you got to get this VR. There's a game that everybody wants. You don't get the sense that the market has figured out, at least in gaming, what it wants to do. But it's arguable that may be about to change, maybe with this Valve focus. Obviously, Valve is a big company, and just I guess last weekend they released one of their Half-Life series, which is one of their most popular series, a VR only game. And there's some suspicion that this might be the killer app for VR. So I'm going to play a clip from that from this new game, just so people can see some of what it's capable of.
So Todd, the audio won't come through by default.
It won't come through.
Yeah.
Okay.
There's ways to do it, but it's tricky.
Yeah. Other people can click on the link if they want to, if it allows. I don't know, or find it.
Yeah. So you can narrate if you want.
Oh, well, it's just like cinematic music, nothing.
Yeah, the frame rate's a little delayed because it's
yeah, okay.
Well, but you can see how atmospheric it is.
You can see you have these hands in front of you. You can see that the graphics are like the high level, I guess they call AAA games. And you can feel the excitement. I mean, I think the main reason that, and we could discuss this later, but I think the main potential for these type of games versus the standard first person shooters is just this feeling of immersion. I think emotionally these games are much more impactful. I mean, you really feel like you're being attacked or shot. It viscerally creates feelings that other games don't. I think the problem is that they haven't quite figured out how to make it feel completely natural. One of the reasons is because even though you have the ability to move in these 6 degrees of freedom, you can rotate around your head, you can move your body, you can't really walk. You can't walk forward like you would in a space. So you actually have to. And people who haven't used VR or people who have, you may know what I'm talking about. But you kind of many of the games, you with your controllers, you can point at an area ahead of you, and then the little light comes out or laser comes out, and then you click on that area, and then you move forward, which doesn't feel totally natural. And one of the things I think eventually they'll be, but they're not there yet. There'll be some standard solution for that. Some people have talked about creating special shoes that have sensors on them so that you can move your feet and then it will act like walking. Some people are even talking about using treadmills, actually 360-degree treadmills to allow you to that would move and allow you to walk in different directions. It's pretty remarkable, and I think the technology is there. It's just not affordable yet. So somebody else talked about architecture. That seems to be one of the industries that really is embracing virtual reality quite quickly. As I mentioned, there's a new library for Unity 3D, Unity, I guess, Reflect, that is targeted toward architects. And you're seeing major architects in New York City and others, use it both for their clients and also internally. Another big area is education and training. here you have a picture of somebody who's a crane operator learning how to use a crane with VR. And that to me, that's just a natural use of it because it eliminates the safety concerns that you would have with training with a dangerous object. Other situations like that would be medicine, where you can do procedures without having to actually operate on a real person. It also can be used in occupational safety, elevator maintenance, other, just basic factory line, people using different machines. I mean, I could see someday we could use virtual reality to teach people how to use things like the welders or the water jets in the hackerspace.
We experimented with a lathe simulator, a lathe safety simulator, and you get to go in and use the lathe, and it makes sure that you turn the right things on in the right order. And so it's a pretty good instructor.
Yeah.
So you're right. We're already looking at it. We haven't implemented it, but it's there.
So I think for anything that's dangerous, to be able to simulate it through VR seems just like a natural use. And that may be more lucrative than I think the gaming thing, which everybody assumes now. Then the last thing.
Sorry to interrupt. I just have a quick question.
Sure.
JR, the lathe simulator, was that developed in the space or was it external?
That's external. It was just downloaded from Steam.
Okay. Thanks, guys. I'm sorry for interrupting.
Yeah, and then another thing could be virtual events, and I think obviously this pandemic situation is making people wonder. Could you have a virtual event where people can socialize in a somewhat natural way within a virtual space? There is one app called VR Chat that a lot of people use as kind of chat rooms. Interestingly, it has the kind of AOL chat room vibe of Wild Wild West. People running around as anime characters and video game characters. Kind of what was that movie? Necromancer, wasn't there? Or Snow? What's the book? There was a book, a popular book about that type of situation in the 80s. Does anyone know? Snow Chaser? No. Anyway, that's always this into the cyberpunk. There's always been this idea that these virtual spaces that people create won't actually reflect the real world. They'll reflect these fantasies of people of being strong and attractive and everything. And you're starting to see that in the way that people are using virtual spaces with VR chat. Okay, so now we'll try to talk about, how would you program in virtual reality? And like a lot of things at the start, you have at the start of any new technology, you have lots of different bifurcation in the market because we don't quite know what the standards are going to be, and you have a million different manufacturers that are producing different devices. So there are, if you wanted to program specifically for a specific device, you would have to learn these SDKs, development kits tied to each device. And there's one for the Steam devices, which Steam does have a way to hook into various devices. You could use the Oculus SDK, which is geared specifically toward the Oculus Rift. Microsoft has their own headset that they've actually, Microsoft is doing it they've done this with other hardware products where they've created a standard and let many different, especially Chinese manufacturers produce devices. So like Acer, Asus, I think there's like 4 or 5 companies that are producing Microsoft devices. There's SDK for that. And then there's also an open SDK that's trying to create standards with mixed success. But most people, especially hackers or people who are just learning, aren't going to start with these specifically with the SDKs. They're going to try to use gaming engines that will create libraries that can then access these SDKs. So you don't actually have to program for a specific device. You can program for the gaming engine, and it will figure out how to compile it to work on whichever headset or build target that you're wanting to use. And a lot of the popular gaming engines, and does everybody know what a gaming engine is? A gaming engine is a software program that simplifies the tasks of creating a computer game. Back in the day, you'd have to, years ago, you might just begin it from scratch, making a game in Pascal or C or whatever. Now, increasingly, people know, okay, we have standard things that we want in a world. We want a physics system. We want the ability to get input. We want the ability to use the graphics card. We want lighting. So there are a bunch of competing game engines that implement these things. And they are creating libraries that can then access all of these different SDKs for the different headsets. And they also are building libraries or toolkits that implement basic solutions for things that you want to do in VR all the time. Like in VR, you're always going to want to be able to pick up devices, throw things around. You're going to want to have a standard ability to move, to twist around at a set rate. A set speed or acceleration. So the VR toolkits have libraries that basically simplify a lot of the standard things. And as a result, a lot of the VR games, if you look at them, they actually look kind of similar because they're all using the same libraries. You're moving in space the same way. So I think most developers, and especially people who are new to VR, are actually working from these gaming engines. They're not just firing up a programming language and working with these SDKs. And that's, I think, increasingly the case because these gaming engines are developing native support for almost all of the major headsets, and they're fine-tuning their graphics rendering pipelines toward the stereoscopic images and the types of images that you need for VR. There's a lot of tutorials for how to use the gaming engines to develop in VR. You can also use the type of 3D environments that you would for a normal 3D game. A lot of these engines have lots of prototyping environments, have different models that you can download that are already well suited for their engine, and it's also a very good way to get started in obviously in getting comfortable with 3D in VR programming, because it pretty much works out of the box. I mean, literally. You can, with a VR headset, there's the Hello World is really just 10 minutes of work or 5 minutes of work with these gaming engines. You just, you load the VR library, you create, a skyscape or a ground, and you can operate it. And they actually, in many cases, you can actually use the VR device through like, I guess it can compile directly onto the device as you're programming. So you can debug and use the device in real time. Okay, so there's basically two main gaming engines. There's actually two. This is throughout almost all 3D gaming. These two gaming engines are dominant, but there's the same in VR. It's the same thing. There's also an open source one called Godot that some people use, but I don't think it's as sophisticated, and it's definitely not as sophisticated in VR. It may be fine, I think, for other applications, for if you're programming in 3D gaming or other 3D artistic pursuits. But I think for VR, my impression is that Unity 3D and Unreal Engine are the two main gaming engines that people are choosing. And like everything in technology, there's huge, endless flame wars and debates about which is superior. But ultimately, it comes down to your personal comfort and the advice of people that you trust. So Unreal Engine, it's now at Unreal Engine 4, is produced by Epic Games, and they're the company that make that battle royale game. What is the game that everyone's playing? Fortnite. And so the Unreal Engine uses C++, which for some people is a little bit harder because of the memory. You have to track memory in C++. But they actually have a more sophisticated, what they call a blueprint system, which means you don't have to code for a lot of objects. You have a visual kind of, maybe I should have had an image of this, but a node system for creating objects and relationships between objects. So you can do a lot of prototyping and programming in without writing actual code. What they call a visual programming environment, basically. Another advantage to the Unreal system is people tend to think that the visuals for Unreal look a little bit better out of the box. You don't have to do as much fine tuning of the options to get a professional image. Although I think that's changing to some degree. And in terms of money, the Unreal Engine is completely free, but there's a 5% royalty that you have to pay to Epic Games if you earn more than $3,000 in revenue, not in profit per quarter. Unity 3D uses the C# programming. And if people aren't familiar with C#, it's a version of, it's a Microsoft created standard that is similar to the C language, but it has a lot of elements from modern object-oriented programming, from visual or from scripting languages like Python or Ruby involved with it. It's a very nice language to use. It's not quite as cool or not quite as comfortable for a lot of people as Python, but I think it's a fairly comfortable language for somebody who's not super sophisticated in programming, and you don't have to do all of the memory type allocations and pointers and stuff that you have to worry about with C++. The visual scripting, however, does require add-ons. There's no visual scripting language that's built into Unity 3D, so you do have to get into code pretty quickly. So if you're not comfortable with code at all, Unity 3D is going to have a little bit of a harder learning curve. But that said, there is talk that there will be a visual scripting language that is going to be launched within the next 6 months or year or so. So that problem will be eliminated. Unity 3D is also developing new graphics rendering pipelines that are specifically tuned for VR. And that's, I think, not just for VR, but they're improving their graphics rendering pipelines generally to allow more professional images to be made without a lot of work. And those are tuned for VR. And that's eliminating some of people's past concerns that Unity, for whatever reason, was more polished. For most people, this isn't a big issue. I mean, you can produce a high, the professional games are made with both of these systems. So unless you just want cool lighting out of the box, or you want something really fancy out of the box without a lot of work, Unity 3D can pretty much do whatever you want. I like Unity 3D better. It has a little bit nicer for version control. Most people say it has a better code. The code is organized a little bit more easily for version control. And lastly, with its license, you don't actually have to buy a license at all. It's completely free unless your revenue is over $100,000. And then you just have to buy the license. You don't have to give them any percentage. Lastly, Unity 3D has a much larger app store or add-on, or I guess they call it add-on store, that has all types of things that you could want: skyboxes, models, 3D environments, lots of things to build terrain, many different add-ons, and they're usually about from maybe $20 to $100. There's a lot of one thing I do say is there's a lot of junk in it, so you do have to look through it. But pretty much, it's quite amazing that for a few $100s you can get a lot, libraries that you would need professional programmers to develop for all types of things within a game. Now, I haven't used Unreal too much, so I can't answer all the questions about how it works. I know Unity much better, but I would tend to encourage people, if they're getting started, especially if they're a hacker type person or a maker type person, to use Unity 3D. Unreal, I think, has a smaller community, so there's not as much learning materials. And I tend to feel that Epic Games is a company that's not as well. It's not producing content, and it's not geared as much toward the maker type creative programmers. Okay. So yeah, what do I like in Unity? I like that the company is quite motivated to teach people who are non-professionals. They have very accessible tutorials. And actually right now, because of coronavirus, they have made their tutorial, online tutorial collection, which normally you'd have to pay like $100 a year for. They've made it completely free for the next 3 months. So that it's actually a good time to start looking at their educational materials. I think Unity has pretty much every feature you would want from a modern game engine. I mean, it really is remarkable the types of things you can do. You can make movies. You can do, as I mentioned, you can do, of course, virtual reality. You can do modeling even inside the engine, sound, positional sound. It's endless. And Unity is also better if you think someday you might be interested in 2D 2D programming. They also have the ability to make 2D games much better than Unreal does. That's obviously not a question now, but it's important to note if you want to learn the software. I feel that the organization of the software, the way the menu system works, and the way the layout is quite good. They're also updating it very frequently. They have a major update every quarter, and you can see what's coming. The downside to that is there are some version compatibility issues, which I'm going to mention. Now, just to give an example of how easily they are, the types of material they're making for people to learn how to program in VR. I'm going to show a video of a project that they just released a few weeks ago that to help people learn how to program VR environments. And it's pretty remarkable what they're giving for free. So again, you can't see the audio, but you could also Google the name if you want.
You could copy the URL into the chat if you want people to be able to view it in their own window.
Yeah, if people can Google that, that might be better for them. Sure. But they're just talking about how we're giving you this VR environment with a little house that has a security system and all these different objects. And actually they have instructions for how to program even in the room itself. So they're, they have little objects, and they have, they have this kind of prototype room to show you how to create scriptable interactions between the objects, and how to make them accessible on different axes and things like that. How to use the particle systems, how to, throw things, or, I guess how to move things and then create interactions if the object goes there to trigger this other physical thing. And you can see there they have, I'll pause on that. They have a link to show you how they do instructions. So they have these lessons that you can kind of get points for, and you finish the task and then move forward. So it's quite accessible and encouraging way to learn how to program. And a lot of this has just been developed really in the last, I'd say, 4 or 5 months. They've made their instructional systems much more geared toward people with not a lot of experience. Okay. So, what do I not like about Unity? Maybe, and some of the things you might not like about it, or I might not like, or you might not like. There may be good reasons for it, but just as a kind of a amateur programmer or a hobbyist, I don't like how they have this. So often when you do a script in Unity, you create a script, it automatically builds this kind of template, script. And it uses this class called this mono behavior class. And this one class has so many methods that aren't part of any domain space, that feel to me like there's these magical methods that are just scattered around this one class. So you feel like you're having to memorize a lot of different methods that aren't organized very effectively. I don't know. This is a pet peeve. They also have a system called prefab. So often when you create an object in in this 3D game engine, normally each object is stands on its own, and its various components, or its gravity, its weight, it can't be shared. So to overcome that, you have to create what they call a prefab, which are prefabricated objects that always have the same features attached to them. And I feel this you end up dealing with this system a lot. I feel like it's a little awkward and it's not quite well integrated, but this is kind of a small pet peeve. And finally, the version compatibility, because they are updating this software all the time. You're always having, just like with Python, you're always having to be aware of what library you're using and whether the add-on that you purchased is compatible with this version of Unity. So it gets to be a little bit of a hassle, but it's not a huge thing, especially if you're trying as much as possible to minimize your use of libraries. Okay, so what makes VR programming a little bit difficult? And as I said, I'm only, I've just been doing a few things, but there is a difference between programming in VR than just normal 3D gaming or 3D environmental programming. One is that you really have to be much more aware of optimizing your frame rates and not creating waste. And that's because you're programming, your device has to be dealing with two large images, one for each eye at the same time. And it also has to maintain a consistent frame rate. And the reason for that is if it drops too low, it ruins the illusion, and it actually can make people sick if it no longer seems natural. So you're having to optimize things a lot more in VR programming than in other 3D programming. There are also constraints on the camera movement. One of the things in VR programming is you can never move the camera around to look at something else, or to move, like you'd see in a normal game, you'd walk around, but then the camera might move to look at another object or show that a door has opened or something's happened. In VR, if you did that, the person would be totally disoriented. So you have to always make sure that the camera is just, this is built into the libraries, but the camera is always showing what your eyes see, which creates a lot of limitations on storytelling or the environments that you can create. You also have to be thinking about avoiding your user from getting sick. So any interaction or any in the game has to be directly tied to the person's movement. If you move them without their permission, they're going to feel like in real life, they've been pushed or they're falling down, and that will create great disorientation. So as I said, a lot of the libraries will deal with this and constrain this, but if you for whatever reason weren't doing that, you could make the person sick, and you always have to be aware of that's happening. And there are little interactions that happen anyway, little bugs that can make the person feel sick, which is quite remarkable for programming, that you have to be thinking about that. VR programming requires a lot of graphic design. I mean, you're not just, you really have to create a real environment. Well, you don't have to create a realistic environment all the time, but I think the burden is higher. And that's why a lot of people, especially hobbyists, will use environments that they have already created. And Unity and Unreal have libraries with prototyping environments, nature environments. A lot of people use environments that are what they call low poly. People may know that aesthetic, the low poly aesthetic of things being much more simplified. That's very common in the VR space because of both the frame rate issues and the need to create these elaborate environments, but without too much design. And then the challenge is just the sheer number of platforms that you have to develop on, from the phone to these different headsets. But as I mentioned, in some cases, the libraries for these game engines will take care of that, but you would still have to test it. You wouldn't, you can't. And so that obviously gets very expensive. You have to have the device to program in it. And that might not be enough if you want it to work on different devices. So that becomes a burden as well. So what are some creative uses? How can hacker type makerspace people, what can we do with VR? Well, as I mentioned, Unity is offering this free access to their learning platform during this coronavirus situation. So there's a new course on VR development that they've developed with Oculus that I think is a really good introduction. And what can you do with VR? And I think that's obviously what we'll spend the rest of this maybe having a conversation about. But I can at least say my interest in it has been soundscapes and musical visualization. I've always been one of those people who love the visualizers in music apps. People may remember Winamp and stuff like that. I've created little add-ons for that. But I think the virtual reality provides so much potential in that space. For people who are familiar with Pure Data, Pure Data is this an audio environment, kind of like Mac's MSP. There are some people that have created a library to patch that into Unity, and I've created a link to an article about using Pure Data in Unity, and that's what I've been working on projects. And at some point I could share that work with people, or we could collaborate on that. I'm also interested in, as I mentioned, I'm a historian, so I'm interested in educating people about history, about historic buildings. In my professional life, I'm interested in a New York City neighborhood called Little Syria, which is the last Arab American neighborhood in Lower Manhattan. And I've been doing historic preservation in that area, and a lot of the buildings in that area have been demolished. So I feel potential in using virtual reality to help people reimagine that neighborhood. And I actually got a grant from a foundation to begin a project with that. We ended up hiring a programmer with NYU to do it, but I'm learning a lot about the technology through that grant. And finally, I think one of the killer apps, and I think maybe something that hackerspace people will get interested in, is when multiplayer or player opportunities become possible. Right now, you can't really, in a shared space, the headsets can't fully interact with each other or play games in a shared space like you would. I guess the way I keep thinking of it is like the laser tag. Imagine if you had a laser tag environment, but you could use the VR technology to create objects and shoot people. I think that's going to create a lot of new type of AR, and that also ties into the AR interest that some people have. I should also mention that programming in VR and AR uses all the same libraries. The only difference is that the AR programming just requires you to kind of set surfaces using the libraries, and then you put objects on top of those surfaces, if that makes sense. I tend to think in the AR, you're often using maybe the SDKs a lot more for if you're doing AR program. A lot of that is mobile devices, so you're probably going to be doing more tuned toward the iPhone or the Android specific libraries for that, if that makes sense. But the Unity 3D and Unreal also have ways to plug into the AR specific libraries as well. Okay, so I've talked a lot. I hope that was a good introduction. Obviously this is a big topic. We don't have the time to get into the languages themselves, but I would love to have a conversation and to talk more, especially maybe think about what could MakeHaven do. We have an Oculus Rift. We have, I think, people who are interested in maybe doing some creative programming together. So maybe we can talk about that as well. So, all right. Thank you very much. I hope that was helpful.
That was great, Todd.
That was amazing, Todd. Thank you.
Yeah. So what questions do folks have? We've often, you can, depending on your comfort, you can either put it in the chat or you can ask it in person. Since we have a small group, that should work out well.
So not to monopolize it, no, I've already jumped in a couple times. So I've been looking at kind of the convergence of what's going on right now and how we can apply different tools. Unfortunately, we don't have things like the knuckle. It's not the knuckles glove. The tactile gloves that you actually put on, like the gauntlets that have the tactile feedback.
Yeah.
And so, unfortunately, we don't have a sense of feel. But I was thinking, well, we have all these mask issues where we're trying to create these masks for people, from sewing to 3D printing. If we had a robot, and I know that there's people who do the robot lab, and they're have their projects where they're trying to go through whatever obstacle course. If we had a robot that could stay in the space and we could virtually control it, whether through VR, whether through our keyboards, however, to monitor 3D printing for different size masks so that we can constantly take off and print once they come off and refill the filament. I mean, I know it's way out there, and I highly doubt we'd be able to pull that off in such a small time frame. But I'm just looking at solutions, things that if we had more tools, or if we have more things already developed in space, then maybe if we work toward that, it would just help catalyze more of the path for the future, so to speak. So as far as participating, I'm a bit jammed up. I would love to be able to chew your ear in about 2 months, just so I can kind of figure out a path to learn more as far as what I need to do to get some basic programming for deving.
Yeah. I would recommend people maybe before, if they don't have a headset now, to just start with learning general Unity programming. I think there's a good tutorial. I think JR just posted a link to learnunity.com, and they have a class that's like a 30-hour class, I think. That's a really effective introduction to Unity 3D. And I think if you might want to learn the basics of Unity 3D before you get into VR, but you could also, I think, I haven't used their new VR, their introduction yet, but I think that might work as well. So,
yeah. Todd, if you want to go full screen, you can stop presenting, and then you'll be.
Okay.
Yeah. We also, so there was an earlier question about twin motion and how that relates to the game engine.
Twin motion?
Twin motion was there's a question, which is an architectural design plugin, it looks like, for, I put a link in the chat.
Oh, yeah.
So maybe you're not familiar with it.
Twin motion, that's that's for Unreal. Yeah, I don't, as I said, I don't know. And I haven't used the architectural stuff. But yeah, there's one for Unity called Unity Reflect or something that's similar to this, I think. Yeah. Oh, this is to create 3D video. Oh, this is for videos. Oh, so you can move people around in your CAD. Yeah.
Right. You generate videos with a gaming engine. You can put people in them, they walk, and cars that drive by and stuff.
Yeah, this program might be more professional or more easier to use than the Unity one. I don't know, but yeah, I think a lot of the issue is the cinematics of it, right? You have to make this is like for making promotional videos where someone's flying around in the space. And I guess they can it looks like Unreal has a way to make that much fairly simple, but I don't know.
And so the other question was just about the learning resources, and I post the learn.unity. Todd, that would be the primary resource. Are there any others that you would say a beginner?
Reddit has a lot. I think actually YouTube is pretty good. There's a guy, Unity there are two main YouTubers that produce, what's the guy's name? He's like a Norwegian guy, or he's a Nordic guy, but he's now hired by Unity. So if you search Unity on YouTube, you'll see a lot of instructional videos about Unity. That's how I've learned a lot.
Thanks so much, guys. I really appreciate it. I've saved those links, and yeah, I will start learning on that in the next few weeks. I appreciate it.
And if people are interested, I don't know if how long we'll be in this situation, but I may do maybe an introduction to Unity class or introduction to Unity in VR class in a few weeks.
That'd be awesome.
I think I'll try to do that. So
yeah, it'd be really neat to watch you place and manipulate some basic objects, even if it's really bare bones. It'd be fun for people, since they can download it themselves, to create an experience.
Absolutely.
And use it.
Okay. Yeah. Very good. But yeah, I think, and once we can all get together again, maybe we can also, do something with the headset that we have, and people can try it out. Because a lot of people, I mean, still haven't tried it out. So you really have to try it out to fully understand it. So.
Can I ask a question?
Yeah, sure.
So it sounds like you're talking about having to program. I mean, you're having to use the programming language to create whatever this is. Is there some way in which to use a 3D modeling program to import it into something to experience this without having to use a programming language?
Well, yeah, I mean, a lot of this is in terms of, you're talking about for your type of situation where you want to move around a model. There may be a built-in program for flying around CAD objects in VR. Like, with the headset, there's a lot of things you can do without programming. You can watch videos, you can play games, you can do things. So there may be already a plugin for your CAD software to allow you to fly around inside of your model. I think that's possible. But whether in this case, if you wanted to create these very stylized videos, you might have to do a slight little bit of programming, or maybe not even too much, but you probably have to load the software and tell it, okay, I want the camera to move from here to here. I want this to happen next. Almost like you're editing a video.
What is the headset connected to hardware wise? I mean, what's it running on?
USB.
Okay.
USB.
Is it a Windows machine or is it a Unix machine? What's it?
I think it works on Macs as well. I think they work on both PCs and Macs.
Okay.
Most of them.
Okay.
Yeah. So Jessica, who's joining us by chat, had mentioned that eDrawings 2020 is introduced as I think a part of SolidWorks, and so that should allow folks using SolidWorks to introduce VR or experience VR.
Yeah.
Which is interesting.
So, yeah. So I think, I mean, one of the things, and I guess we didn't have this full conversation, but I think the last thing I would like to say is we really don't know how VR is going to be used yet. It's an interesting time when there's all this hype about it, but it hasn't quite broken through. And it feels like it has all this potential. So I feel like it's a time for creative people to experiment with it. And we may, by having conversations and by playing around, I think we may find things that the corporations won't. And I think that's how a lot of technologies develop. So I think that's one of the reasons it's good that MakeHaven has this, and we have a dialogue about it, because we may just come up with ideas ourselves that are the killer apps for this.
Great. Well, with that, Todd, thank you so much for taking the time to walk us through. I think this is a great introduction and really gives people a taste of what's under the hood. I'm sharing in the chat for folks a evaluation. So if you have any feedback on the session, please do share it with us that way. But for now, I'm going to stop the formal recording. And thank you very much. And if folks have some additional questions to ask after, maybe you'll stick around for a second. But
okay.
this ends the formal session.
Okay.